So the learning outcomes for today is we will be using these ultrasonic sensors, so which effectively are eyes, right? So it can see an object ahead of it and tell you the distance between the object and the sensor. So we'll use that. But the main learning outcome for today is stepwise refinement, and which is really a process to develop the software, right? Or to develop a program. So I focus more on the process today. Now, before I go on to the stepwise refinement, I just quickly wanted to talk about this ultrasonic sensor here. Okay, now now there are loads of ultrasonic sensors that are available in the market. The one which we would be using is this one. Its name is on the top, which is HCSR04. Okay, it should be written somewhere here. Yeah, it says HCSR04. So that's what. And this is the data sheet for this sensor. If you have got your own ultrasonic sensor, which you may have, if it's not this one, then another version of it is which is having 3 pins. So this sensor which we are using today has got 4 pins. Yeah, these 4. Some sensors have got 3 pins. We'll work with the 4 pins one. And effectively in the 3 pins one, the middle 2 pins are, a single pin does the work of the 2 middle pins, which is trigger and echo. Okay. Now, if you have got 3 then you need to open the data sheet of your own sensor. So read the name, go to the Google, type it, and then you will get a data sheet. This is the data sheet for this sensor. What I'm going to do now is I'll tell you basic principle how it works, and then I'll switch to stepwise refinement. We will do a practical example of how to do stepwise refinement with this ultrasonic sensor, and then I'll give you some work to do. The basic principle of measuring the distance of object is, if I want to measure a distance, for example, how away is this camera from me? So I'll throw a hello packet. Yeah. So I will trigger, or I will throw a hello packet. The packet will travel as a wave, as a sound wave. The packet will hit the object, and the packet will come back. And I will time it. I will say, okay, so I've got a packet, I'll throw it, and I'll say, okay, so it takes packet 2 seconds to come back to me. And I know the speed of the sound. What's the speed of the sound? Obviously you don't know. And if you don't know, so let's try to find the speed of the sound. Where is the speed of the sound? Did I write the speed of the sound somewhere? No, but what is the speed of sound exactly? Speed of the sound is yeah. So speed of the sound is 1/29 centimeter per microseconds, if I remember it correctly. So how much is 1/29? This much, isn't it? So if I copy it, okay, so let's round it off, isn't it? So how much would that be in round off? What should we say 0.03 then? Or should we say 5? Yeah? That's the speed of the sound in centimeter per microsecond. So if I take sound and I say hello, I echo a word, and I get it back and I time it, and suppose my time is 10 microseconds. So how far is that object away from me? What's the distance between me and the object? If it's 10 microseconds it took for me to hear my voice back, how far is the object? You'll drive cars. How far?
0.3 centimeters.
How much?
0.3 centimeters.
0. Yeah, so because you multiply it by 10, isn't it? Yeah, so in one microsecond, sound is traveling 0.03. In 10, how much it will travel? 10 times. So 0.03, and then, but then you have to divide it by 2 because sound is going and coming back.
So 0.1 going.
Exactly. So actually, the distance would be 0. This much multiplied by 10 and then divide by 2. Everybody happy? Yeah? So that's the basic principle how you calculate the distance of the. This is heavily used in ships to measure the depth of the sea. Fine. Okay. In this ultrasonic sensor, you have got 4 pins, and you can read the data sheet. The link is in the PowerPoint slides, which is in the movie. So you've got 4 sheets. VCC is the voltage one that goes to 5 volts. G and D, the last one, it goes to ground. Brilliant. You have got 2 more pins, trig and echo. One is called as trigger, and that is a transmitter. T for trigger, T for transmitter, and E for echo. Echo is receiver. So what happens is, you have got a trigger and you have got a receiver. The trigger throws a hello packet. So when you put a high voltage on the trigger pin, so suppose trigger pin is connected to pin number 2, okay? Yeah? So if trigger pin is connected to pin number 2, so if you do like this, yeah? So digital write to high, which means pin number 2 is high now, right? And this means my trigger pin is high now. The moment trigger pins becomes high, it throws a hello packet. Okay? That hello packet is then received by the echo pin. When the echo pin receives the packet, echo pin becomes high. So, if you initially make the trigger pin high, so if you say digital write to high, so your your trigger pin would become high, and immediately it's throw a packet. And if then you start timing it, and then you keep a watch on the echo pin to find out when the echo pin becomes high, that would be the distance the object has come back. Is it clear or not? No? So effectively, so you've got trigger and echo. Trigger is a transmitter, it sends a packet. Echo is the receiver, it receives the packet. When you make the trigger pin high, that time it throws a packet, and then you start ticking. You start recording the time, and then you keep a watch on the echo pin and find out, maybe you put a LED on echo pin, and when the LED is on, that means echo pin is high. Echo pin is high, that means echo pin has received the hello message. So you will know the time, that how much time it took for the packet to go and come back, and suppose that was 10 seconds, then your distance becomes 0.003 into whatever that is into 10 divided by 2. Is this basic concept clear to everybody? Okay, so that's how this sensor works. Okay, if it's clear to everybody, then let's go to our main learning outcome for today, which is problem solving and stepwise refinement. Okay, in order to do that, let's start from here. If you read the first question, and then I talk about it. So this is the lab exercise which you should be doing today. Everybody clear on exercise 1? Okay. All right. So in exercise 1, you have to create a bell alarm using ultrasonic sensor, speaker, and LED. If the object comes less than 25 centimeter, then your alarm should be switched on, and your red LED should be turned on. So we will do this. We will create program for this using stepwise refinement process. And even before we do that, let me just give a trivial example of stepwise refinement.
Are you mentioning in Java or
Arduino. Stepwise refinement. Suppose I ask you make a program to prepare tea. Yeah? Or I say there's a robot which can do tasks. Write a program on the robot so that it can make tea. So what would you write? What would you write program? So you will say begin, end. Yeah? So that's begin and end. So what did you say? Yeah, tell me.
Fill kettle with water.
Yeah, fill kettle with water.
Get PG tips.
Water,
PG tips can be a bit proper.
add milk. Yeah, something of that sort. Now, if I say my line number 4, add milk. If I say to a robot, add milk, can the robot execute this statement? No, why not? Well, suppose it knows how to add milk then. Suppose it knows what the milk is. No, why? How much? Because your instruction is still vague. You understand in your head that tea requires this much of milk, but to a robot, it's not an instruction which can be executed. So then what you will do is you will start with this one, and then you will drill it down further, isn't it?
Is this what we were doing like 2 or 3 weeks ago when you went through each different code and refined it more and more?
Exactly. So that, yes, that's exactly a stepwise refinement process. So in a stepwise refinement, we start with a, a high level process, and that's our step 1. That's our refinement 1, the first refinement, and then we go for the second refinement. We break down the task into smaller tasks. Second refinement. So let's do the second refinement with this. So that's my, first refinement. That's my second refinement. And in second refinement, I can be with add milk 1 ml maybe. In the second refinement, I will pick up each instruction and break it down into smaller steps. And then I will go for the third one. Now tell me, how many iterations should I do? Should I do 3? Should I do 10? How many? When should I stop?
You can't do any more.
No. You should stop when your instructions are detailed enough to be executed. Then you stop and you write the code. Yeah? Now let's take now this was a very trivial example. Let's take a proper example, which is this one. So I copy this. Okay, so this is my problem. Yeah? Problem. First iteration. If I we always use begin and end, all right? And maybe we make them in capital letter. Okay. Yeah. So begin. So tell me what if you were to write the program. Yeah.
You start with whichever pin is connected to, would you write, for example, pin 2 high trigger the licensing?
Okay. I slightly want to avoid that for now. Somebody else, tell me what would you write? Yeah. So tell me.
Is the second stage or the first stage?
First stage.
First stage.
High level. First stage. So maybe calculate distance.
Activate the alarm system first, so it's actually got power.
Yes. Okay. Switch on power, for example. Yeah.
And probably check the sensors, etc. to make sure.
Yes. Well, we don't want to go into that right now. So let's still keep it to high level. So I think the second would be, as you said, calculate distance, isn't it? And again, your first iteration can be different from somebody else's first iteration. Maybe your first iteration is detailed enough to actually write to a program, in which case it's brilliant. Maybe somebody else's first iteration needs further refinement, in which case you can go to step 2, step 3. But eventually the goal is to reach at a level which can then be converted to a program. So calculate distance. What's the third one? I got the distance. Then what should I do? Yeah, April, what should I do? Oh, so I just, so that's my, Yeah, so that's my problem. So if I have got the distance, then I should switch on the speaker, isn't it? Yeah, so what should I write here? So I've got a distance now, calculate distance, and then?
Check it against the 25.
Yeah, so check is less than 25. If yes, yeah, or as a trivial example, right? Beep and yeah, as simple as that. And this is, by the way, this is known as pseudocode. Some people call it PDL, which is Program Design Language. And effectively, at the end of the day, this is the way the system or the way the algorithm or the way the process would work in a very informal English type language. Okay, so I have done that. So that's my first iteration. My question to you would be, so how many lines of code are there in the first iteration? 4, 7, 8, 9, 10? Which lines in this code is detailed enough to be converted to Arduino code straight away? So, can you convert this to Arduino code straight away? Huh? Yes, because you can easily write yeah? Okay. Then this step, line number 9, doesn't need further refinement because you can convert it to this step, calculate distance. If I copy this calculate distance and paste on the Arduino, will Arduino understand? No. So this line clearly needs further refinement. Now let's get to the task. That how? So that's my first iteration. Now my second iteration. All right. Okay. And switch on the power. I don't really need to because it's nothing to do with the program, isn't it? It's a manual process. Why just remove that? I don't touch these either. I just focus on line number 19. So that's my one statement, which is very high level, which needs further refinement. Now the question is, to calculate the distance, what should be done? Physically, what is the actual thing that needs to be done? And in order to do that, you have to focus on the things that I explained to you. So if you were to measure the distance through this ultrasonic sensor, so the first thing that you need to do is, of course, you physically connect the pin number. The first pin goes to the voltage, the last pin goes to the ground, and trigger and echo goes to maybe pin number 2 and 4. So what the first thing that you need to do? To calculate distance, the first thing that you need to do is throw a packet, throw a wave, yeah? Throw a sound, for example. And then record the sound. Or no, throw a sound, listen for the sound, and record the time. Does it make sense? Yeah? And again, some of you maybe when you are working, you may come up with a different subtasks. But one of the subtasks could be, this could be converted into 3 subtasks, which is transmit sound, yeah? Listen for sound on something. Is line number, can you see it from the back? So line number 19, 20, 21, is that clear? So this is a more in detailed way of recording calculating the distance. And again, I want to focus 2 things here. We want to learn how the ultrasonic sensor works, but the other really main learning outcome is this process actually, the stepwise refinement. So some of you may be brilliant at coding and programming. I give you a program and straight away you write the coding and it's brilliant. Some of you, including myself, when I see a program, I don't straight away write it. I think for a while that what should be done, and I mentally I do this stepwise refinement process, and then I do the things. Okay. So my on my first iteration, my task was calculate distance. On my second iteration, I broke it down to 3 steps: transmit sound from the trigger, listen for the sound on the echo, and record time. There's one fourth step that I need to do. What's that? Once I have got the time, how do I calculate the distance? What's the relationship between distance and time?
0.03, so they're up.
Yeah, but then let's make it generic. So if the speed is something, yeah, yeah, speed, right? So won't you say something like this? So multiply by time. Does it make sense? All right, and then you have got the distance. So your one line, which is line number 8, which is calculate distance, has been broken down into 4 lines. Yeah. And this is the real process of stepwise refinement. One task, you break it down into further subtasks. Out of these 4 lines, which is the line which is ready for transferring to the Arduino, which can be just written onto Arduino and it will be fine, or very near to? Yes? Which line?
22.
Yeah, 22 is fine because distance equals speed times time. That's fine. So you can just port it into Arduino and it will work fine. So, if you really wanted to port it into Arduino, you could have something like, yeah, of course you will have to define your speed and time, but then, you will have it. Okay, line number 19. Line number 19. If I copy line number 19 and put on the Arduino, will Arduino understand this? No. How should I define it further so that Arduino can understand it? How when I say transmit sound from trigger, what exactly do I need to do? Throw a packet, yes, okay. But how? What should I do? Huh? Yeah, that's what it will. Turn the pin on. So all you have to do is, this is high level. You have to drill it down to really low level, so you can then go to your third iteration. Yeah, third iteration is transmit sound from trigger. That statement can be replaced by a more refined statement, which would be, yes, set. That's it. The moment you set it to high, it will throw a packet immediately. Okay?
Will it continuously do it, or will it?
No, it starts continuing. Yeah, it starts. Yeah, it starts throwing a packet. Okay. So trigger is set with. Listen for sound on echo. This is like, once you throw the packet, once you make the trigger pin high, that means you've thrown the packet, and then there's an echo pin in which you are keeping a watch on it now. So you're saying, oh, let me see when the echo pin becomes high, and then you record the time, isn't it? That's what it's saying. Now it's a bit tricky to do that, but okay, if you read the description of this function and tell me what it may be doing. Samantha, what it may be doing? Yeah, exactly. So yeah, go on. No, go on.
I was going to say, if it's low, the pin is low, then it will time, and it will time it until the pin goes high.
Yes.
But you can also set a timer, so it will stop listening if there is no pulse within a set amount of time.
Exactly. So effectively, this is your listening function. So if you said something like this, this function, this line, if you wrote this line, then it will, so what it will do is, it will say pulse in is a standard Arduino function. Echo pin, it takes two parameters, one is echo pin and one is high or low. If you say echo pin, so whichever pin is your echo pin connected to, suppose it's connected to 4, it starts listening to the pin number 4. And it will tell you the duration when that pin becomes high. Does it make sense? So what you will do is, you will do line number 33. So suppose if I do something like that, I set it to high. So how do I set it to high?
Digital, right?
Yeah. Yeah. The moment I done this, a packet has been thrown, and the very next thing I will do is, this. I will say line number 2 executed, a packet is thrown, and immediately I will say start listening on the echo pin. The pulsing function will start listening on the echo pin, and it will listen for what? It will listen for high, which means when that pin will become high, it will stop and it will tell you how much time it took to become high. That time will be the time in which the packet went and came back. Does it make sense or not? So, this line, which is listen for sound on the echo, can be replaced by this line, yeah, which is a pulse-in, use the pulse-in function, or you can probably leave it that way. What about line number 35? Do I need that? No, because duration already has it, isn't it? My duration function, duration variable already has recorded the time, right? So duration done. And then this line, is that fine? Or maybe, am I making sense or not?
Well, we have to define duration first, though.
You have to define this.
Otherwise, it's not going to know what it is.
Yes. Okay, I define it now. All right. But in the pseudocode, you can probably leave the actual int and all that, because the real benefit of the pseudocode is in plain English, and then it can be written on for any language. So we try to use, even we should not have used pulse in function really, but no harm in using it really. So, okay. Now the big question now is, third iteration, is that detailed enough that if I give you third iteration and say write the program, would you be able to write it?
Yep.
Yeah? So this is the stepwise refinement process. We started with the first iteration and we wrote something. Then we switched on to second iteration. We wrote something which was more detailed version of it. Then we went to third iteration. We further broke down the process. And then we stopped at third. Why? Why did we stop at third? Be detailed enough. Sometimes it may require 10 steps to be detailed enough. Sometimes it may require 2 steps to be detailed enough. But the end goal is you should stop when your pseudocode or program design language is detailed enough to be converted into a code. Okay. Once we have done it, now let me show you the actual code. All right. So this is your code, and let's switch on to the actual code. Okay. This is my real code, and by the way, this code is all available from this link, Ultrasonic Sensor. All right. So I have got this code from here now. Line number 33. What's line number 33 doing? Okay, line number 33 translates to line, how many lines? 1? Line number 30 translates to 1 line. In this code, which is a standard good code, line number 3 translates to these 5 lines. My question is why? Why do I need, yeah?
Is it doing the whole process of calculating the distance?
No, the whole process comes down.
So you've got a gap between each one.
Yeah, because of the delay, I suppose.
Otherwise, it will continuously do it and get.
No, no, not that, not that. The reason is this. This is a standard one, which is because it's saying set the pin mode to output, because the trigger pin is a transmitter pin, so we want to transmit it. So it's an output mode. The echo pin, will that be in output mode or input mode? Input, because you are listening, right? So my echo pin will be in the input mode. But apart from that line, these lines are because of this. My trigger pin, when it becomes high, it throws a packet, and I want to trigger the packet throwing. I want to start the transmission, right? If I set it to high, it will transmit. But what if it's already high? You want a clear high, isn't it? You don't want, like if I say there's a button, if you switch on the button, something happens. When you come to it, maybe button is already on, that thing has happened, or something, So you want an unambiguous high. Does it make sense? So what you will do is, you will first switch it off. And then on again, because then it's a clear, unambiguous start of the transmission. Does it make sense or not? So this is a practical thing to do, really. Yeah. Even though if you do that, your code will work probably fine. If you just have one line, most of it. But you want to take care of the situations which may happen in real life. So you want an unambiguous, clear high. Sometimes the pins and all that go into a kind of slightly ambiguous phase, wherein they are not high, not low. With electronics, things happen sometimes. So you want to first make it low and then high. Okay. A very, very, very trivial and unrelated example is I don't know if you do it, but when I make tea, right? So I always throw down the water of the kettle and then fill it from scratch. So I always first make it low and then turn it high, because not really related, but you see what I mean. Okay. So in this case, so first it's setting it to low and then setting it to high, right? So it's an unambiguous high. So that's our line number 18 to 22 done. Line number 19, line number 3. Line number 3 has been transferred to these two lines, 27 and 28. 27 is very obvious, which is echo pin is a receiver pin. So you have to put it into an input mode so that it can listen. So line number 27. And 28 is the easy stuff, which is, you use the pulsing function, make it listen on the echo pin, and listen, when it becomes high and give you the time. All right? Okay, so so once you have got the duration, then what this may be doing? This is converting duration to centimeters. Yeah, you could probably replace this line easily with something like what is the speed of light we calculated? This one, isn't it? So you could very well write like this: Cm equals and this function pulse in returns me the time, but what is the unit of time it returns me? It's in microseconds. That's why when I got the speed of the light, I didn't get in meters per second. I got it in centimeter per microsecond. Yeah, because duration pulse in returns me microsecond. But instead of writing like this, we have written a function which says microseconds to centimeters. And where is that function defined? Here. And if you quickly read it, you will see, this function is exactly what we have. Oh, we did not divide it by 2. Did we divide it by 2?
Yeah.
Yeah, we did divide it by, no, where did we done? Yeah, we divided by 2, isn't it? So that's fine. Yeah, so this is the function, microseconds. So they are doing the same thing. Yeah? So divide by 29 by 2. Is it? Now once that has been done, this has been done, then this is straight from our code, isn't it? Which is line number 37 and 36. Okay? And then you beep and then you switch on LED, you can do. So beep and then you could say, this is right, I already written that. Yeah, so my pin becomes high, red pin becomes high. Okay. So what's the take home message? The take home message is this is stepwise refinement process. You begin, you write lines on a yeah. So at each step you see if the action requires further clarification. If it requires further clarification, then you break the main task into subtasks. And when you're doing the subtask, you take care of sequence, selection, iteration if they are necessary. In this case, what did we do? Did we do selection or not? What is selection? If else. So we did do if else, isn't it? So we did do selection. Did we do iteration? No, it was not required, so we did not do iteration. Okay, and so sequence we did. And also, when you are having it, you need to store the variable somewhere, which we did, which is, where is in the final iteration. Yeah, so in the duration variable we stored. We did not declare a data type about duration because we will do that when we are actually writing the code, which is here. Centimeters, so we must have defined the centimeter somewhere, which is here. Yeah, so it's long. It's not int, but it's long. Okay. Okay, that's just what we did in the class. By the way, for this stepwise refinement, there's a famous paper by Nicholas, and that's an ACM paper, which all of you should read. I have uploaded that paper in Moodle as well. This paper was written, I suppose, in 1971. Yeah, and it's a historic paper. But the principles explained in this paper, which is stepwise refinement, are still very, very much valid. So read the paper. Okay, we talked about ultrasonic sensor. There is this nice video about the sensor. Where is the video? Here. And I want all of you to see the video before you begin the task, so you get a good understanding of how the sensor works. All right. So, and the code for getting the sensor work, I have got this code from this link. So that's the code which we discussed. So everything is on Moodle. Pulse and function we already discussed. One more thing. So now tell me, would everybody of you be able to do the question number 1? Yeah.
I was going to just ask, when do we find our groups?
I'll come to that in the end, yeah? So would everybody be able to do the question number 1? Sure? Okay. Question number 2. Question number 2, you just have to extend your program, okay? And instead of, in addition to beeping and switching on the LED, you also have to display an alert box on the PC. So you have to use serial communication to talk to between PC and your Arduino. And the way you do that is, last week I gave you this Java class, okay? And in this Java class, last week you used this function which is sent to Arduino. So you were writing to the Arduino. There was one more function here which was reading from the Arduino. So you have to use that function today. And that function, reads the value. So you read the value and do some manipulation and, use io.display. Do you remember io.display Gloucester jar? To display an alert message box if its value is more than certain threshold. Okay, but the main thing is do the task 1. Once you finish the task 1, then switch on the task 2. Some of the students will make this mistake that this is the function I gave last week. So when you are using this function, you will do that. You will open Eclipse, yeah, and you will copy this, and here you open Eclipse, and then you will put it, and then you will see loads of errors. Well, right now maybe I could open Eclipse actually. Yeah, this is what some of you may do. So if you do that, why would you see errors? Because you just copied a function and not the whole class. So this is just one function. Read Arduino, all right? So this is just one single function. Yeah, so effectively what you have to do is when you are copying it, copy the whole, because there are import statements on the top which you have not copied, so you will get an error for that. And there is this one, so it's public class, so many students won't probably copy this. So yeah, so make sure you don't just copy the function, but the whole class. Okay. And is question number 2 clear to everybody? Okay. So what I want you to do is do the question number 1, and I've got the ultrasonic sensor, so you can take one and do it, and then do the question number 2. Where is my? Okay. Now, while we are waiting for this stuff, now regarding your groups, I'm sorry I couldn't work on the groups last week, but I'll work on the group right now in the lab, and I'll let you know your groups. I mean, by default you will be on the group which you asked for. Otherwise, I'll just about randomly allocate you to some group. All right? Okay, so some of you will do that. So I just close it, cancel it. Where is my project? CT4003. This one. So some of you will do that. New class, and you will say read from Arduino maybe. Yeah. And then you'll say finish. And out here, you will just copy this function and then paste it. And immediately you will see loads of errors, isn't it? Because this is just one class, one function, and not a class. You have to surround it with the class as such. Okay, so generally it's surrounded like this, public, and whatever the file name is. So now it's fine. But then you will get other errors. Anybody can tell me why I'm getting other errors? No, it's not about COM5, no. Before even COM5 I'm getting error. So cannot resolve comport edit because I have not imported the file, imported the classes. You see on the top you have got loads of classes here. Alright? So I just import the classes and the errors will be gone, hopefully. Gone? Everything. What's the other error I have got? Input cannot be resolved. Yeah, okay, because there are some things like this one, I didn't copy it. Yeah, now everything should be gone. Yeah, gone, up and running. So to be on the safe side, the best thing is to copy the whole class instead of just a function. Okay, so let's get started with the stuff. And yeah, so I'll give you the group right now, and you can start working on your project. Next week, have come up with a small half a page of text of what you want to do, and you can just start working on it straight away, really. All right.